Hey guys, so here we are, truly week one of virtual learning. I'm going to upload videos for your notes. You'll have notes in there to print out for your use. If you can't print out, then just write notes as you watch the videos. So you have those to help you when you're doing your big idea assignments. Okay, so one thing that's going to be really big this week is you have to have a calculator. So I'm going to go over some calculator options with you that you can get at home. Some of you already have a calculator, which is going to be really useful for you. I'm going to switch over for a second. So if you have a phone, you can use this standard calculator that comes with your phone. And that will be enough for what we need to do. We'll just have to turn it sideways to get these sine, cosine, and tangent functions on your calculator that we're going to use this next week. Okay. If you're more comfortable with the calculators we had at school, you can go to, if you have an iPhone, you can go to the App Store or whatever store that you're using on your phone and search. You can put scientific calculator, but graphing calculator. And you will get some versions that are good. So we have a TI-84, and this graphing calculator says it's designed for TI-84, and this is the one that I have on my phone, Calculator X. So you can download that. That's a great app. If you have an Android phone, Wabbit EMU, I'm going to write it down here so you can see it. Wabbit EMU is an app that looks exactly like our calculators at school too. So if we go look at here, that's my Calculator X. So it looks just like the graphing calculators we see at school. We have the sine, cosine, and tangent buttons that we're going to need for this week's lessons. If you don't have any of those, or if you don't have a phone and you're just using the computer, you can go to desmos.com. Oh wait, that's graphing, that's not fine. Sorry, I was thinking algebra. Okay, Desmos is not going to work for you because we're not graphing anything. Maybe it does. You can go to scientific. Yeah, there you go. You can go to scientific calculator and you have sine, cosine, and tangent there. So there you go. Options. All right, so let's start our actual notes. Okay, so we're going to talk about specifically a tangent today. And we're going to use a ratio. So a ratio is just like a fraction. It compares two numbers. My kitty cat wants to join us. And we're going to use those in solving some problems in real life. We're going to enter the branch of mathematics that is trigonometry. And I'm excited because this is my favorite thing in geometry. I actually have a shirt for this, and I was so sad because I got it dirty. But I will definitely wear it when we get back to school. Trigonometry is a branch of mathematics that studies relationships involving lengths and angles of triangles, more specifically right triangles today. So we're looking at those, finding lengths and angles of triangles. So our trigonometry, there's a lot of vocabulary, a lot of things to write down. So I'm not going to pause the video and give you extra time to write this. You can pause on your own and write them down, okay? Our trigonometric ratio is a ratio of two lengths of the sides of a right triangle. And three common trig ratios are the sine, cosine, and tangent. So we're going to talk about all three of those this week, but we're going to start with tangent today. Our tangent is a trig ratio for acute angles that involves the lengths of the legs of a right triangle. And we're going to look at angle of elevation, the angle that an upward line of sight forms with the horizontal line. And so my camera here is blocking your image. But if I look straight ahead and I see a building that is 2 or 3 stories tall, the ground makes your straight line for the ground. And then looking up at the top of the building, that angle is our angle of elevation. So the angle I'm looking up. Okay, so we're going to see these abbreviations a lot. Tangent is just tan. Opposite, we say OPP. Adjacent, we write ADJ, just to shorthand. Okay, so here's a right triangle. If I look at angle A straight across the right triangle is the opposite leg. And then right next to A is my adjacent leg. And then the hypotenuse is always directly across from the right angle. Okay. So our tangent ratio does not involve a hypotenuse at all. The tangent of angle A is the length of the opposite. Let's see if I can move this. Oh, I can move it. There you go. So the tangent of A is equal to the length of the leg opposite divided by the length of the leg adjacent. So if we look at our picture here, the opposite leg is BC and the adjacent leg is AC. Okay, so opposite over adjacent is going to give us the tangent. And A is the measure of that angle. All right, so if we find the tangent of S and the tangent of R, we're going to write each ratio as a fraction and a decimal rounded to 4 decimal places. Now that's weird, right? 4 decimal places. 4 decimal places is because long time ago, before we had this wonderful invention of calculators that do sine and cosine and tangent for us, we had big books of tables for sine, cosine, and tangent, and they were all rounded to 4 decimals. So be thankful that you have a calculator that does all this for you, and you don't have to look in the back of your book at lots and lots of tables for these answers. Okay, so tangent of S, we'll have to do it separately. The tangent of S is opposite over adjacent. So if we look at S, opposite leg is the 80, and the adjacent leg is 18. So we're going to do 80 over 18, and then reduce the fraction. We can simplify by dividing by 2. Or if we type it in our calculator, 40 divided by 9, we get 4.4444. All right, now looking at angle R, we got to go back and look at R. R, opposite of R is 18, and then the adjacent of R is 80. So we have a fraction of 18 over 80. And we can reduce that by dividing by 2. If you notice, those numbers look the same, it's just the reciprocals, right? So 9 divided by 40 is 0.2250. All right, then we're going to find the tangent of J and the tangent of K in fraction and decimal form. This time we're going to do 2 decimals. So Big Ideas is going to tell you how many decimals to round to if it wants a decimal. If it doesn't tell you and the fraction answer gets you a wrong answer, always use 2 decimals. Okay, so our tangent of J is opposite over adjacent. So if we look at J, the opposite is 24 and the adjacent is 32. We simplify our fraction so we can divide by 8. And we get 3/4. Type in 3/4 to your calculator, or you might know it, you get 0.75. Tangent of K, we look at angle K. Starting at K, we get 32. Adjacent, we get 24. Again, same as above, but it's the reciprocal. And then we simplify by dividing them both by 8. We get 4/3. Rounding to 2 decimals, we get 1.33. Okay, now you have to have your calculator, and we talked about that. It's very important to set your degrees to radians. Okay, so I'm going to switch over real quick. Okay, so how you do that on your calculator is, if you're using the normal calculator that comes on your phone, there's a little button in the corner that says rad. If you hit it again, that's in degree mode. Okay, so if you hit, you always want that to show degree. Maybe. We'll play with that. That's making me nervous. It says rad up there. We want it in degrees. Okay, we'll play with that in a minute. If you're using your regular graphing calculator, you go to the mode button, and you're going to go down to where it says angle, and you want degree highlighted. Okay, so if you have a calculator, a real physical TI calculator or Casio, its automatic setting is radian. So you have to change it anytime you change batteries, anytime you reset the memory. You have to go into the mode and change it back to degree. Okay, and then we'll exit out. All right. Okay, we have this 30, 60, 90 triangle. We want to find the tangent of A. So if we look at A is 60 because it's the degree of the angle. Our opposite is square root of 3, and the adjacent to A is 1. And if we put that in a calculator, we get 1.7321. So the tangent of 60 is 1.7321, and that holds true for any triangle any 30, 60, 90 triangle. Try to get this out of the way. The tangents of all 60-degree angles are the same constant ratio. Any right triangle with a 60-degree angle can be used to determine this value. So it's constant, any triangle. Okay, find a leg length. I'm going to go to a paper to show you this because it's easier to see there. Okay, so example 4, finding a leg length, find the value of x. Okay, so we're given the angle 32. Across from that angle, is 11. So that's our opposite, right? And our adjacent right next to it is x. Okay. And that is equal, opposite over adjacent is the tangent of A. Or tangent of 32, right? Sorry, 32, because that's our angle, 32. So whatever your angle measure is, if you know it, it goes with that tangent. Now to solve for this x, we want to multiply by x on both sides to cancel the fraction. And we get tangent 11 equals the tangent of 32 times x. Now we want to solve for x, so we're going to get x by itself by dividing the tangent of 32 on both sides. So that cancels here. We have x by itself. And we're going to put this in the calculator. If you have just the regular calculator, you're going to type it in exactly how you see it. So you do 11 divided by tangent of 32. And I get 17.60. So if it doesn't tell me how many decimals, I'm just going to put 2 decimals. Okay. Now if you're using your regular calculator on your phone, you have to do 11. It's going to be a little bit different. 11 divided by, now I have to put 32 in first and then do tangent and equals. That gives me the same answer. Okay, so 11 divide 32 tangent equals. Okay. Example 5. I'm going to find the value of x. So we're going to start with the known angle. And opposite of that is 22. The adjacent is x. It's equal to the tangent of 61. So we're going to get rid of the fraction. By multiplying by x. So we get 22 equals the tangent of 61 times x. And then we want to solve for x by dividing by the tangent of 61 on both sides. So this will cancel. And then we solve for x. If you're using your graphing calculator, type it in. 22 divided by tangent 61. Enter. You get 12.19. Okay. I'm going to go back and show you on your regular calculator. We're doing 22 divide 61 tangent equals. And there's your 12.19. Okay, example 6. Our angle of elevation. I'm going to zoom out a little bit here. Okay, we have an angle of elevation. We're measuring the height of a spruce tree. So they're big and tall. We stand 45 feet from the base of the tree. So here's our 45 feet down here. You measure the angle of elevation from the ground to the top of the tree to be 59 degrees. So that's our angle of elevation. We're looking up. Now, I don't know if any of you have seen tree climbers do this, but some of them do climb up to the very tippy top of those branches and drop a humongous tape measure down to the bottom of the ground and have somebody measure. Now, that is a lot of work to measure a tree, and you can do it without the dangerous part. If you watched old sea movies, more specifically Moby Dick, or anything that they're out in the sea, I think 20,000 Leagues Under the Sea, they also have these instruments where they look out at the ocean and they measure how far the sun is up, and there's like a little scope that measures up. That's how they measure the degrees for the angle of elevation. So it is done in real life. You may see surveyors when they survey a property, they want to know how tall the building is. They use those instruments as well. Okay, so these are not made up numbers. It really does happen in life. All right, back to our problem. From the ground to the top of the tree was 59 degrees. We want to find the height of the tree to the nearest foot. So we're not going to be dangerous climbers. We're just going to use our brains to get the numbers, right? Okay, so if we know, we want to find h, the height of the tree. So we have the angle, we have one side length, and we can find the other side length. Okay, so we know the tangent of 59, that's our angle, is equal to the opposite, which is h, over the adjacent, which is 45. Now this time we want to cancel the fraction, so we're going to multiply by 45. Multiply by 45. That cancels, and we get h is equal to 45 times the tangent of 59. So a little bit different equation there. There we go. Okay, so we're going to multiply 45 times tangent of 59. And we get 74.89. And I'm going to show you on the other calculator as well, just to get used to it. 45 times this time our tangent of 59, so we're going to put 59 first and then tangent equals. We get the same answer. Okay, now our instructions say find the height of the tree to the nearest foot. So we need a whole number, so that's about 75 feet. And that's a lot more accurate than a long, strung out tape measure that has to find its way through all those branches of a tree. All right, example number 7. Yeah, we got more after this. Find the height of the lamp post. So I want you to take your time, pause the video, see if you can figure this problem out. Did you pause? I'm waiting for you to pause. Okay, I'm going to trust you, and I'm going to believe that you paused your video and you're checking your answer now. Okay, so we have the lamppost. Our angle of elevation is 70 degrees. So our tangent of 70, opposite is h. Our adjacent is 40 inches. So to solve this, we're going to get rid of that fraction by multiplying by 40. That leaves h by itself. So we're going to multiply 40 times tangent of 70. You get 109.899. That would make it go up to 90. 109.9. That's really, let's call that 110 inches. Okay. Right now, what if you had to give it in feet and inches? Because 110 inches, I have no concept of how big that really is. I know it better in feet. So change that to feet. We're going to do 110 divided by 12. We get 9.1166. So it's really 9 feet, and we have some leftovers, right? So 12 times 9 is 108. We have 110 total, right? So there's 2 inches left over. So a little bit of extra conversion there. All right, last example, number 8 on your next page. We have our boy flying a kite. Here's my art lesson for you today. Here's my little boy. He's flying a kite. The angle of elevation is 18 degrees, and the kite reaches its maximum height at 300 feet away from the boy. Okay, so the kite is 300 feet away from the boy. And if you draw the ground, its angle of elevation is 18 degrees. What is the maximum height of the kite? So they want to know, how high did it go? Okay, so we have our angle here, and we have the opposite, and we have not the opposite. Okay, sorry, I messed up there. 300 feet away from the boy means 300 feet this way. All right, so we have the opposite and we have our adjacent. So we have a tangent of our angle is equal to the opposite h over our adjacent 300. So we cancel the denominator by multiplying, and we put that in the calculator. 300 times tangent 18. We get 97.475 rounds to 8. Using your other calculator, if you choose to use it, you do 300 times 18 tangent equals. There's your same answer. Okay, so this whole time, this rad is showing. If we push it again, that makes no sense. This is actually radians. You know, we want the rad to show, to have that degree measure. Okay, so kind of ignore what I said before. You want that rad to show for degrees. All right, well, that's the conclusion of notes for 9-4. Your big ideas assignment is in 9. Your big ideas 9-4 assignment is ready for you at Big Ideas. If you guys have any questions or need help, please ask, let me know, comment on your assignment, email me, text me on Remind, come to Zoom 10 o'clock and 2 o'clock every day. All right, I miss you guys, and I hope to see you soon.